Today we are spinning your words round and round, counting the number of duplicate characters in a string, and then we are converting red, green, and blue color values into their hexadecimal representations. Hello world, and this is Versus Codewars. We begin today with the warm-up segment. 3 simple katas to warm up for the more difficult katas later on in the episode. We start with a word. The goal of this first warm-up kata is to return the middle character of that word. If that word's length in characters is odd, we are to return the middle 1 character. Otherwise, if that length is an even number, we have to return the middle 2 characters. Let's go ahead and give this a try here. Our function signature is going to be constant get in middle. It's going to take a string as a parameter. Alright, what we'll first need to do is get the length of that string, and what we can use is the object destructuring logic to get to that, pull that length straight out of the string like this. What we'll go ahead and do from here is return if the remainder of length divided by 2 is 0, indicating that this is an even number. We'll go ahead and, I think it's str.slice. Slice. We probably will need to get the midpoint here too. Math.floor length divided by 2. And what we'll go ahead and do is we'll get the midpoint, slice from the midpoint to, I think, midpoint plus 1. Or is this exclusive? But not including the character indicated by the end. So this will actually need to be plus 2. Alright, we slice the string starting from this midpoint up here to 2 characters ahead in that string. The slice does not include the last character indicated by the second parameter here. Alright, well, and otherwise, if the length of this string is an odd number, we can just go ahead and do this. str at midpoint. Alright, let's go ahead and punch this into Codewars and see what that looks like. Let's change this to str here. Let's try submitting it. Alright, let's log that string, see what's going wrong here. Try -1. Alright, let's try -1 here. Let's punch this into Codewars and see what that looks like here. Just kind of go ahead and copy all of that. Let's try submitting this. Alright, let's try submitting this now. And we are good on that one. Alright, the next warm-up kata is called Isograms. An isogram is a word that has no repeating letters, consecutive or non-consecutive. The goal of this kata is to determine whether a string is an isogram. Assuming the string contains only letters, the string is not empty. ignoring the letter case. Let's go ahead and try this here. Our function signature is const is isogram. It takes a string as our lone parameter here. First, we're going to go ahead and convert that string to lowercase, const to lower str. What we can actually go ahead and do is str equals str.to lowercase. I think we'll go ahead and keep an array here. Const letters encountered. We'll set that to an empty array. We're going to go ahead and iterate through each character of our string here. Let's console.log that and see what that looks like. Feed that in a node, see what that looks like here. And we get each of the characters of our test string here. What we'll go ahead and do is, if letters encountered that contains char, we return false. Otherwise, we push that into our letters encountered array. And if we reach the end of this block here, we'll return true to indicate that the string is, in fact, an isogram. Let's go ahead and feed this into Codewars to see what that looks like. I can take all that, actually. Copy that, paste. Let's try submitting it. Problems here, too. Contains is not a function. Alright, let's try that again. Includes, not contains. Alright, let's try that again. And we are good on that. Alright, the third warm-up kata is called You're a Square. The goal of this kata is to determine if an integer is a square number. Let's go ahead and give this a try here. Const is square equals number. And we will return true if this is a square number. And we can do that very simply by doing this. Return math.square of number modulo 1. So the remainder of the square root of this number divided by 1 is 0. If the remainder is 0, then this number here will be a perfect square. Let's go ahead and feed that one finally into Codewars and see what that looks like. And we are good on that. That concludes this morning's warm-up section. Let's go ahead and proceed to the next kata. Given a string of one or more words, the goal of this kata is to take all of the words in that string that are 5 characters in length or greater and reverse them. Let's go ahead and give this a try here. I think what we'll go ahead and do is return str, the string that we passed in. We're going to split that using a blank space delimiter to get the individual words out of the string. We'll take the resulting array and run that through map. Passing in our word into our predicate function, this map method will go ahead and take each word, check to see if its length in characters is greater than or equal to 5. And if it is, we'll go ahead and do this. Word, we'll split the word into its individual characters using a blank string as a delimiter. We'll reverse the resulting array, and then we'll join those reversed characters back together with a blank string delimiter. Otherwise, if this word's length is less than 5, we'll just go ahead and push the original word into the resulting array. Now that we have each of the words 5 characters or greater in length reversed, we can go ahead and take that resulting array and join it back together using a blank space delimiter. Alright, let's go ahead and punch this into Codewars and see what that looks like. And we are good. Not really much to say about my submission here, but I want to show you a more clever solution I came across here. Pay mind to the code snippet you see below me, and pay mind to the regular expression here. During a kata in the previous episode of versus Codewars, I was talking to you about character classes and quantifiers in regular expressions. How if you had a number in between curly braces after a certain entity in a regular expression like a character class, that regular expression will look for that specific number of instances of that character class in a string. You can have 2 numbers in those curly braces separated by a comma, and that regular expression will look for a certain number of instances of that character class in between that range of occurrences. Like, for example, if you had 5 and 10 separated by a comma in the curly braces, it will look for anywhere between 5 and 10 consecutive occurrences of that character class in the string. In the solution you see below me here, you see a 5 and a comma, but no other number inside those curly braces. That tells the regular expression to look for at least that many occurrences, consecutive occurrences of that character class in the string. We have this replace method here, which takes that regular expression and a replacement value, which is the return value of a function, where any match to that regular expression is replaced with that word split into its individual characters, reversed, and then joined back together with a blank string, much like what I did with the map method in my submission. By doing this, we save 2 calls to the string's methods and pull this kata off with only 1 string method call, the replace method. Given a string containing alphanumeric characters, the goal of this kata is to calculate the number of characters that occur more than once in that string. Casing is ignored. Let's go ahead and give this a try here. First, let's go ahead and take this text and translate it to all lowercase, because casing doesn't matter here. Alright, what we'll go ahead and do here, we're going to go ahead and get the characters of this here by taking the text and splitting it into its individual characters. What we'll go ahead and do here is return chars dot reduce it's going to take a cache and a char for our arguments in our predicate function, and the initial accumulator here is going to be an empty object. What we'll go ahead and do is, in our reduce method's predicate function, we'll return our cache and set a property whose key is equal to the value of char here. We'll take that and set that equal to char dot, cache char equals if cache char is defined in this object, we'll go ahead and take that cache char plus 1. Otherwise, if this is null or undefined, we'll just go ahead and set this to 1. Alright, let's first console.log that with a random string here and see what that looks like. Console.log duplicate count. We'll pass in our random string here. Let's feed that in a node and see what that looks like here. Node counting duplicates. And we should have our cache with the number of instances of each character in our string. What we'll go ahead and do with that, you know what, it might be a better idea if we tried this with an array. With what I have in mind, it might be a better idea if we did this with an array. Alright, I'm going to go ahead and redo this. We're going to actually return array with our cache here. Yeah, it might be a better idea if we tried this with an object here. Never mind that. Just going to undo that. So we've got our object back here. What we need to do I have an idea. What we'll go ahead, well, we'll go ahead and do here is, since this is returning an object, we can run this whole thing through object.keys. To return the keys of this object as an array. And what we can do from here is run that do.filter, passing in our chars into our predicate function here. We're going to filter out anything in the resulting keys array in which the number of occurrences of that particular character in our object here is 1. And we'll do that by doing this. And for this, we will need the predicate array. No. Yeah, that ain't gonna do it all. Well, I have an idea. What we'll go ahead and do here is we're gonna get rid of this filter here for right now. We actually will want to save this here. Copy. We're going to save this in a variable. Occurrences, cache. So we're going to actually go ahead and take this resulting object and store this in its own variable. We're going to call it occurrences. What we'll go ahead and do from here, return object.keys, occurrences.filter, char. We don't need this, but we do need access to... No, actually we don't. Alright, we're going to go ahead and do this from here. Occurrences at char is greater than 1. Alright, so what we're doing here, we're taking this text that we pass in when we first convert it to lowercase because casing is insensitive here. We then take that text and split it into its individual characters with the split method here. We then get a cache, an object, containing the number of occurrences of each character in the string here by taking the characters and running it through the reduce method. And it returns an object here with keys corresponding to each character of the string, each unique character of the string, and the number of times they occur in the string right here. We then take the resulting object and run that through the object.keys method to get the keys of that object in an array. We take that resulting array and run that through the filter method. And in the predicate function, we take each individual character here, and we filter out any character in the string that occurs only once therein. Hence this. Now, the goal of this kata is to return the number of characters in the string that occur more than once. So what we can go ahead and do with this resulting array, we can just go ahead and return its length. Alright, let's go ahead and feed that in a node and see what that looks like. And we do have 2 here. Let's try another one. Let's feed that in the node and see what that looks like. And we get another 2 here. Alright, I think we're all good. Let's go ahead and feed this into Codewars and see what that looks like. Try to submit it. And we are good. Here is the better code solution of the day. Pay mind to the code snippet you see below me here. What I could have done was taken the character array returned from the text.split method and run that through the array object's filter method, utilizing all 3 parameters in that method's predicate function: the current character, the index of that character in the array, and the array itself. I could have run that array through the index of and last index of methods passing in that current character, and determined if there was more than one occurrence of that character in the array by checking to see if the return value of index of and last index of were not the same. Given 3 integers representing the red, green, and blue values of a color, the goal of this kata is to return that color's 6-digit hexadecimal representation. We have this function here with 3 arguments: red, green, and blue. And we need to return that 6-digit hexadecimal representation. Let's go ahead and get started here. First, we need to make sure any values that fall out of that range are rounded to the closest valid value. Let's go ahead and do a little helper function to clamp a value here. Actually, what we can go ahead and do is yeah, let's do that helper function here. If const clamp equals num upper and lower. If num is less than lower, return lower. Else if num is greater than upper, return upper, and return num. We have our basic clamp helper method for clamping a number now. What we'll go ahead and do with that is red equals clamp red 0 to 55. Do the same with our green and blue values here. And green. Alright. Blue and blue. What we can go ahead and do with this, I'm going to do a quick console.log here. Console.log red to string. We're going to pass in 16 for our radix. What this will do, this will convert this integer into a hexadecimal representation. Let's go ahead and try that here. I'm going to do a little console.log here. Actually, just do an RGB call here. 148, 0 to 11, for instance. Let's feed that in a node and see what that looks like here. In fact, that's not supposed to happen. Let's console.log that red here. Oh, yep. Lower and upper. Yeah, let's go ahead and continue here. We run the toString method on this number here, and we pass in a radix of 16 to indicate that we want to transform this into a hexadecimal representation, because hexadecimal is base 16 rather than base 10. We should get 94 here. Let's repeat that with our other two color values here. We should have a 94, a 0, and a D3. Alright, what we'll need to do here is... Alright, we're going to go ahead and capture these in the strings here. Const red hex equals red.toString 16. Or what we can rather do is we'll return these and do something like this. Red.toString 16, green.toString 16, and blue.toString 16. What we'll do from here, we're going to map those out, passing in a value to our predicate function. And what we'll do is value.length is equal to 1, then that's to say if the resulting value string has only one character with it in it, then we'll go ahead and prepend that with a 0, otherwise just return that string. And then we should be able to join that together with a blank string. Let's feed that in a node and see what that looks like. We obviously need to console.log it first. And we should have a hexadecimal value of 9400D3 for an RGB of 148 red, 0 green, and 211 blue. Now, as you can see here, these need to be uppercase. So we'll just go ahead and take that resulting string and run that through to uppercase. Run that through node again. And we should have the correctly capitalized hexadecimal representation of our color. Alright, let's go ahead and feed that into Codewars here and see what that looks like. Run the tests. Our clamping should be working alright. And we are good. Instead of that helper function that I wrote in this Kata solution, a better way to clamp a number between a lower bound and an upper bound is to just use the math.min and math.max functions. Call the math.min function first, passing in 0 as the first parameter, and for the second parameter, the return value of the math.max method, taking in your upper bound and then the number you want to clamp as the parameters in that method. And that will do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to my channel to see me take on more coding challenges on Codewars. As always, if you think there's anything I can do to improve on my code, feel free to make a suggestion in the comment section below. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.